All right, in this video, we'll talk about market demand. Market demand is just the sum of all individual demands from buyers in a market. So we can see graphically, suppose we have three individuals here. This demand table shows us at any given price, what are the quantity demanded by each individual, and then to find the market quantity demand, to plot out the market demand curve, each price, we simply just add up all of the individuals. Okay, so conceptually, hopefully that's not too complicated. What's a little bit more confusing is trying to do this mathematically with equations. All right, notice here that this market demand curve might not be perfectly linear, right? We've got this consumer A here is not willing to purchase at any price 4 or higher. Okay, so what's this doing? At a price below 4, we have 3 consumers in the market, and we're just adding up those quantities to find this market demand curve. But at prices above 4, consumer A drops out, and we only have 2 consumers in the market. So we're only adding 2 consumers to find this section of the demand curve. All right, again, the moral of this story is that if consumers' maximum willingness to pay, which we can see as the y-intercept on their demand curve, right? This is showing us that consumer A's max willingness to pay is 4, or in other words, 4 is the price at which consumer buys quantity of 0. Right, because this consumer's max willingness to pay differs. Up here at prices higher than 4, this consumer is not in the market. We're just summing these two. And down here, we're summing all 3. Okay, so how do we do it mathematically? Well, when we're just summing up these demand curves, what we want to do is have it in Q equals form. Because, again, we're just summing up these demand curves, and the demand curves are at any given price, what is the quantity demanded? So if you have, say, a function like Q quantity demanded equals 10 minus P, you plug in any price, it spits out quantity demanded. We just sum those up for every consumer. All right, so if we had one consumer with a demand, quantity demanded equals 10 minus P, a second consumer, quantity demanded 15 minus P, we just sum those up, we get 25 minus 2p. All right, but then the caveat is the consumers might be entering the market at different prices. So the slope, or the demand curve that we just found summing everybody up, is only for prices that everybody is in the market. So coming back here, prices below 4, everybody's in the market, so we sum everybody up. At prices above 4, only 2 people are in the market, so we have this kind of discontinuity in demand. And then the idea is, in general, if we have enough consumers in the market, most markets are composed by many consumers, so these discontinuities eventually would become kind of small, and maybe this would look more smooth and curved rather than discontinuous sections. Okay, so market demand and handling market demand is just a case where we need to kind of be able to use both the Q equals form and the P equals form. Why do we use the Q equals form? We use the Q equals form because that allows us just to add up all of the demand curves. That's what we're doing here. And in order to do this mathematically with equations, you write Q equals whatever function of P for each consumer, and then you just sum them. But we also know that that total sum of all the consumers will only apply to prices where all of the consumers are in the market. So we need to figure out what price that is. Well, that price is the y-intercept. And in order to see what that y-intercept price is, we need P is a function of Q. So basically what we would be doing is, all right, once we have all of the demands in Q equals form summed up, we know what this section of market demand is, but we need to find this price. How can we find this price? Well, that's the y-intercept in P equals form. Right, so again, you're kind of using both forms here. You're using the Q equals form to actually sum up and find what the equation is for market demand. And you're using the P equals form slope-intercept form, the standard slope-intercept form, right? Price is on the y-axis, so we need that to be our response variable as a function of quantity if we're accurately graphing this. So we find our y-intercept, we see, okay, consumer 1 is not in the market at prices above 4, so we would write that this market demand is the sum of all individual demands for prices less than or equal to 4. Okay, I put some examples of doing this. Definitely in the example problems, and I think also in the review guide that I have posted to the midterm 1 module. So take a look at that. Right, elasticity we covered kind of back in chapter 2, but that's still on this exam, so make sure you're familiar with that. Let's talk about consumer surplus. So consumer surplus is the distance between demand and market price up to our actual quantity sold. So what is this saying? Consumer surplus is saying, well, our demand is consumer willingness to pay. Right? This shows us one consumer, or I guess this is 1,000, but ignore the thousands. Anyways, one consumer would have been willing to pay this price for it, but only has to pay the market price. So this whole area here between the demand curve, the willingness to pay, and the market price is surplus. Right? People would have been willing to pay $18 for the rock concert ticket, but they only had to pay $14. So that's surplus. Right? Some people would have been willing to pay $17, $16, $15. They all only had to pay $14. So that is surplus. Right? Price they would have been willing to pay minus the price they actually had to pay. And then we're just going to take that out to the market quantity. So mathematically, how we're doing this is we can just find the area of a triangle. And it gets a little bit more complicated. Suppose that this was non-linear. Now we don't have a perfect triangle and we have to start using calculus to find the area between curves. But in this class, we're just going to study the linear demand case, which means we can use the area of a triangle formula. Right, we can see our area of consumer surplus, again, extends from the demand curve to price all the way out to quantity. The area of a triangle is 1/2 base times height. All right, with a right triangle, it doesn't really matter which is the base and which is the height. They're calling this side the base, that's fine. I might have called that the height, but you're just multiplying, so it doesn't matter. So we're going to take 1/2. This side, how long is this side? Well, we have 20 minus 14 equals 6. And then how long is this side? We can just see what the quantity is. That looks like 6.5 thousand or 6,500. Right, so the area of our triangle, 1/2 base height, or 1/2 height base, doesn't matter which. 1/2, 20 minus 14, times 6,500. All right, more generally, the formula for consumer surplus is going to be 1/2 the y-intercept of the demand curve. All right, and once again, remember, it's worthwhile to keep in mind when you need the demand or supply equation in what format. Here, if we want to find the y-intercept, we need it in slope-intercept form, which means having our y variable as a function of our x variable, which means p as a function of q. Then we can see our y-intercept just from that equation. It'll be the constant in that equation, p equals form. So we've got 1/2 y-intercept minus market price times quantity as our general format. Okay, again, put some example problems in a couple different places. In the week 3 module, there's some example problems, and then in the midterm 1 practice module, there are some practice problems. Our last topic then for this Midterm will cover chapters a little, just a couple topics, really some definition stuff out of chapter 1, and then mostly 2 through 4. So we've assumed so far that individuals' demand is independent of other people's demand, right? Then we can just add up total individual demands as the sum of market demand as the sum of individual demands, right? It's possible that other people's decision-making could impact your decision-making, or one consumer's decision-making could be impacted by what other people are buying. This is what we call a network or peer externality. I think in my notes and study guide, I talk about it as a peer externality, peer demand externality, means the same thing. So we've got a positive network externality, which we call the bandwagon effect. The bandwagon effect just means the more people are buying this item, the higher demand is for the item. More people want to buy it because more people are buying it. And then the opposite of this effect would be the snob effect, which is where as the product becomes more affordable, more people can buy it. This actually reduces demand some because of what we call the snob effect, where people want exclusive goods. So the more quantity demanded increases, I guess the more this snob effect dampens it. So basically what we're saying is that when the price decreases, the snob effect, for a normal good, when the price decreases, demand is going to go up. We're saying with this snob effect, demand will still go up, but demand is going to go up by less than it would have without network externalities. Right? We get a price decrease, quantity demanded goes up, but it goes up less than it would have because some people are saying, if everyone can afford this, I don't want it anymore. Right? The positive network externality is saying, suppose price drops, quantity demanded should go up. Quantity demanded is going to go up by actually even more than that, because as more people buy the product, more people want to buy the product. Right? So they work in opposite directions. Once again, I've got some numeric examples there in the practice problem and also in the midterm review. So let me know what you think. Let me know if you have any questions.